Today we're going to model with exponential and logarithmic functions. First, determine the type of function represented by each table. To understand the type of function, we need to look at the differences between the x's and the differences between the y's. For part A, the x's are equally spaced by 1 point, and each y value is multiplied by 2. So as x increases by 1, y is multiplied by 2. The common ratio is 2. Because you have a common ratio, you know it's an exponential function. If it has a common difference, you know you have a linear function. The x's are equally spaced by 1. These differences do not show a common difference or a common ratio. So this xy relationship does not represent a linear or an exponential function. But that's just when we're looking at the first differences. Let's look at the second differences, the finite differences between the first. The second differences are constant, so the data in this table represents a quadratic function. If you had a table where the third differences were constant, then the data in the table would represent a cubic function, and so on for polynomials. Number 2, write an exponential function y equals a times b to the x, whose graph passes through 1, 6, and 3, 54. I'm going to write two equations and plug in each of these points. If y is equal to a times b to the x, let's plug in x and y. For the point 1, 6, y is 6 and x is 1. For the point 3, 54, y is 54 and x is 3. Now we have two equations with two variables, so we can use substitution to solve. So our exponential function is y equals 2 times 3 to the x. Just like when you were given 2 points and you were asked to find the slope, when you're given 2 points that represent exponential growth or decay, you can find the common ratio, or the base of the exponent. Data do not always show an exact exponential relationship. When the data in a scatter plot show an approximately exponential relationship, you can model the data with an exponential function. A store sells trampolines. The table shows the numbers y of trampolines sold during the xth year that the store has been open. Write a function that models the data. Begin by making a scatter plot of the data. The data does appear exponential, so choose any 2 points to write a model, such as 112 and 436. Now plug them into your exponential functions and use substitution to solve for a and b. After rationalizing, we get 4 cube root 9. So our exponential function is y equals 4 cube root 9 times cube root 3 to the x. Or when writing with rational exponents, 4 times 9 to the 1/3 times 3 to the x over 3. When you're doing these problems in your textbook, they'll want you to plug these into a calculator and give a decimal approximation of a and b. And that's modeling for exponential functions.